listen up. So this is week 5, part 2, and we're in chapter 5, which talks about multimeters and meters we will use in the field. So we have 3 main meters that we use all the time. This one is called a multimeter. Because it has a voltmeter in it and ohm meter. So first we have a voltmeter. We have also voltmeter pin. We have ohm meter. And we have actually clip-on meter. That's meter's amperage. So I'll bring my finger pen so you can see how it works. Yeah, bring this grab me station cord, another one. So if you have
In a workshop?
Huh? Yeah.
In a workshop?
It's in there. Here. So you will need all these 3, and I'll show you how they work and how they are different from each other. How do they work? They deploy Ohm's law, and they also have a magnetic field that will measure the field around each wire. And we said every wire has a magnetic field generated around it. So we have a combination now. Back in the days, this is an analog multimeter. They still, you can see something like that, where they measure volts. So this is a voltmeter. And you have to carry a voltmeter with you, and you have to carry an ohm meter with you, and the clip-on meter. So there were 3 different tools. So this is an old one, and basically you clip it into the equipment, or you probe it, and it will tell you what is the voltage here, whether it's AC and DC. And again, there's always options to measure AC and DC. Luckily, we don't have to use these ones anymore. I mean, you can if you want to, but they're not that convenient. We have now the multimeter, which measures different things with one equipment. So this one will measure everything except regular amperage. With regular amperage, we need a clip-on, unless you have very small amperage, which says here microamps. Okay. You always want to make sure you have. Thank you. That you set up. That you set up the meter on the right setting. What happens is, in some different meters, they have different ports for AC and DC. If you mix it up, you burn it. Any mistake you do, the equipment will go wrong. These ones are more expensive because they are foolproof. Even if you put it in the wrong setting, it might give you an error, but it will not break. And, huh?
How much are those ones?
It varies depending on where you get them, but I think it's worth between 150 till 250 depending on the functions and the models. This one is a Fluke 116, and give you true RMS, which is root mean square. So what does that mean? It's more accuracy. It takes measurement over like 100 times and divided by 100, so it gives you like very accurate average results. This accuracy is very important if you're going to work with small equipment that has milliamps. If you work with this, for example, this is very small components, and you need to know the accuracy of each one of those components. So we know they work with Ohm's law. And somebody said last class, this has a battery in it. It has a 9-volt battery. The battery is important to measure voltage. What happens is I send small amperage, and I can measure the voltage by that. actually the resistance, and it has variable resistances in it. And we have some glare here. So now we have 0, but you do not have to put ranges. Some other ones you have to put the range for the resistance. This one has auto ranging. If you look at this one, the clip-on, it still have ranges in it. So this is from 2 amps. Can you see it? See how it says 2 amps, 20 amps, 100 amps? That's the range. So it does not do auto ranging. You have to put it around the same ranges. So we'll do a few examples in the lab. We'll do the same thing. I'll have you go and test for all those measurements. And again, we said the clip-on here, if you look at it, it has also some measurement here. The maximum is 100 amps. It's really hard to see. Can you see it?
Why don't they make one without a clip-on that does the amps?
It's very hard to have resistance that will measure a lot of amps, and you have to put it in series. And think about it. That's a good question. When you measure voltage, you measure in parallel. You put your probes in parallel with the circuit. When you measure amperage, you want to know what's going through the pipe. So you have to go do it along the pipe. For example, along the wire or pipe. Oh, this is gone. So let's think about it this way. If I have voltage here, I'm going, and I have a load. My current flow is going this way. If I want to measure the voltage, I'm going to put my voltmeter between the load. See how much did I drop. If I want to measure the amperage, I'll have to put something in the flow to measure how much flow is there, like a flow meter. If you want to measure how much water or gas is flowing through the pipe, you have to put a flow meter with it. It cannot be outside. So that's the reason. If you have very small voltage, you can run it through in series. Otherwise, you have to cut the wire and put your wire inside. That's why we always rely on the magnetic field, and the accuracy of this instrument also add to the price and the quality of it. Let's do some. Let's start with this one. First of all, what does the voltmeter pin do? Just tell you if there's voltage or not. So if I have my wire here, I want to test for voltage. If I touch it through the wire, I should get something. So this is the blue. And this is probably the neutral. It's very thick insulation, but at least I know if there's light, that means there is some kind of voltage in it. This multimeter has also this property. If you look here, it will light up. Sure, light up. It's not that strong, but if you put it into the NCV, it should give you. See, it's detecting voltage. Okay, now let me measure the voltage. So you can measure what kind of voltage do you expect from a household receptacle? 110, right? Is it AC or DC? DC. Huh? AC. Alternating current, which looks like this squiggly line over here. And now this tells you the accuracy. This is what it's measuring right now for some reason. So I'll take my probes. And you agree that one of those holes is hot and one of them is neutral and one of them is ground. Which one is the neutral? Bigger one. Thank you. Who said that? Excellent, guys. I didn't even know that until recently. I'm impressed. So I'm gonna have to complete the circuit because I'm running through the resistors in here. So I'm gonna stick one in here, and the other one in here. And it's giving me the voltage.
Did you get shot from that?
No, unless I'm touching the metal part. I see moving left now. What is the other way to do it? If it's not convenient. If you go there and the whole neutral is covered up, there is nowhere to plug. I'm gonna put one in the hot.
One on a piece of metal.
No, which is the ground.
Yeah.
I still get 115. If I put it between the neutral and the blood, I get nothing. 0.9 volts probably is nothing. So this is how I measure voltage. How do I measure frequency? And what is frequency again? Lincoln, you said last time? Frequency? Hertz, which is what? How many cycles per second? If you look here, there's an HD. So I'm gonna toggle with the yellow part. I'm gonna stick it in and see the frequency. What do I have? 60. That's really good. That is very accurate. So 60 is what we need, which is how many up and down we have in 1 second. So we got the voltage now. This is for voltage AC. If I want to measure the voltage of a battery, you get a battery and measure it, but it does the
Want a
same
battery?
thing. You have a battery? All right. Intense battery. All right, so let's try voltage DC. Why is it giving me minus? Right, that, which means also it has to do with direction, right? So that's not a problem. 3.4. Volt DC. You see what it says volt DC? The light is it better now?
Yeah.
Clear? So again, see minus to plus, I get volt DC. And we have the auto range working out here. Huh? I just give you the negative flow of voltage. What else do I want to measure? This is for, what is M means? Milli, which is part of 1,000. Millimeter, 1 millimeter is part of 1,000 of a meter. Milligram, part of 1,000 of a gram. So it's very, very small voltage. So what produces very small voltage? Thermocouples. So, or some other small equipment. Resistance, let's measure something, some resistance. This is a transformer. What's inside the transformer? A lot of winding from the inside. So I'm gonna measure this lead here. Luckily this is ready for us to try. 11 ohms. Make sure you watch the, sometimes it tells you what resistance do you expect, so you can test it. So one of them is going to be really high and one of them is going to be very low. So this is 11.2. This, when you measure resistance, is the power on or off? Off. Never measure resistance when the power is on. See, this is 1 ohm. So 1 ohm is going to be the low side. It's going to be the low side and the high. This is the high side. We'll learn about that in the transformer chapter. But this is how we measure resistance. What about this thing here? Continuity, thank you. So if I have a transformer, I want to know if the wire inside is cut without like opening it up. I just touch the two sides and it should give me beep. So back in the days when you used to go and try to fix a VCR or a TV, the electrician will use the continuity part and go through every small little components and find which one is broken, and he will weld it out and put another one in. Question?
If the wire was broken, what would it be?
Nothing. It's zero. Good question. Let's try that tomorrow. But if the wire is broken, if the light bulb is broken, you get nothing. If the fuse is broken, you get nothing. What about this thing? This is to measure the capacity capacitor. I think I used to have some over here. There's a capacitor, there's a relay. Let's play. So these capacitors you'll see in a lot of motors, and a lot of ACs. The unit of a capacitor is a microfarad, MFD. So this is 6 megafarad. So it's going to be 6,000 farads, and it will hold voltage up to 370 VAC. So let's. What is VAC again? Voltage alternating current. We're gonna try the microfarad and see what I get. First of all, when you deal with a capacitor, you want to touch it together. Make sure it's not charged. I know this one is not charged because it's been here for a while, but never test the capacitor without knowing if it's charged or not. And how do you do that? You touch the two terminals together, and they should spark. Small spark. It's not that bad. But if you have a bigger capacitor, it's a big spark.
You're not gonna blow the capacitor or anything like that?
No. So this is giving me 6.5 microfarads, and it's supposed to be 6 microfarad. This is microfarad. There's different notation. So it's a very good capacitor. With capacitor, usually you check the shape of the container. If it's bulging, if it's leaking, you know it's a bad capacitor. What's inside here used to be wool, used to be oil. Now they put oil, they put some kind of chemicals in it. Over time, it gets bad. Temperature. If you have to, and if you have this option, usually you can measure temperature. I had a thermocouple here at some point. Show us. I did. Okay, but you put the leads on here, and it says open because there is no temperature sensor. I'm using the leads now, touching each other together, and it's giving me 70 degrees. So this is what a thermocouple does. It just 2 leads together. The temperature here apparently is 70. So let me touch it and see what happens.
So will it measure your body temperature?
It's supposed to. Yeah, see, it's going up. Slowly. So it measures temperature.
I'm sure the other lead's more sensitive.
Yeah, they're more sensitive, more calibrated to temperature. So these are most of the functions we need to use. So if I ask you what multimeter you need in the field, you need a voltmeter pin to detect the existence of voltage. You need a multimeter with at least VAC, VDC, ohm meter. Continuity will be a nice option, but these are the most important ones. And you need to test the microfarad at some point too. Oh, here it is actually. Here's the thermocouple. And what is thermocouple? You should know that at some point because this is the new thing. We do not use thermometers or liquids or anything else. We use thermocouples, which are 2 wires connected together. And if you heat it up, you should see it's more sensitive. The sensitivity of thermocouples depends on the welding job here. See how it's spot welded? And the type of wire, see how thin it is? So they are very expensive to make, to purchase. Probably one thermocouple will cost you around $30.
Why is it spot welded?
Because you want to mix the metals together, and you don't want one to be more than the other. So you have to spot weld it. So it's something you can make yourself if you want to, but you have to know the tolerance of the wire and how much voltage does it make. Okay? What else do I want to talk about? There are some very important facts in the book that we should go over. For example, the accuracy. This is chapter 4. Here are some pictures of analog meters. They still have also clip-on analog meters. Book is here. It's a very common one. It's one of the I like how rugged it is, and it's very accurate. I've seen a lot of people in the industry. Klein is another one, and this actually is reasonably priced. Klein is around 250 or 300. You can get different models for.
Older technicians probably still even prefer the analog, huh?
Yeah, I don't think so.
No?
It gets annoying because it wobbles a lot. You have to wait and stabilize. This one will give you more direct reading. So, these are, I want to show you where they put the accuracy. It was here somewhere. Voltmeters. Look at the ranges. Most voltmeters go up to 600 volts. If you need something more than that, probably have to buy a specific voltmeter. And ohmmeter circuits. There are some information here you do not need to know. For example, if you're using analog meter, it will show you infinity if it's open. If it shows you it's short circuit, we're not going to use that. I want to see the part where they give you the accuracy plus or minus 5%. Keep changing. Okay, here you go. The digital voltmeter has plus or minus 1% of the actual reading. That's pretty accurate. So plus 1%, plus or minus 1%. Analog is about 2% of the full scale, plus or minus 2%. So the digital one is more accurate. Microfarads, options, yeah. And in the summary, they tell you about 80% of the problems in all equipment is electrical. The only mechanical part we have is the motor, or the oil burner. Probably it could be the pump. Those are the mechanical parts. The other ones are mostly control, and they are getting more and more reliable. But if you have problems, you have to go and do some kind of electrical troubleshooting. So let's read through this chapter for Friday. We'll do the questions together, then we do the quiz. Any questions about multimeters? How to use them? Again, this kind of stuff you want to do yourself. It's not something I can talk about and just show you. That's why we're doing a lab. We're going to have a lab where you go and measure voltage, measure amperage, measure resistance. We did the resistances in parallel and series, and we know what to expect out of them. Let's try to tackle some of these questions. Since we're here, we have time. So, what are the three most common electric meters used in the industry? Ohmmeter, voltmeter, and clip-on meter. Think of Ohm's law and think of the three components, and you want to measure each one of those components. I'll put down the triangle. And you can add the voltmeter pin to those. What is the most analog meter used to facilitate needle movement? What do you think? Ohm's law, a magnetic field that flowing electrons produce, inductive resistance, or all of the above?
C.
All of the above. It does use Ohm's law. It does use a magnetic field that flowing electrons produce. That's how we move the needle. And inductive resistance. And what is inductive resistance? You know, you might have to deal with the analog display for some meter. If you go to our boilers, probably you will have to look at that at some point. Okay, they do not explain that, but I'll show you. What is inductive resistance? Did anybody ever dissected a radio? Look, what's in it? Huh? So you will see, if you look at the small needle in any digital meter, you'll see a coil. This coil is going through a wire in the middle, and at the top of the coil there is a wheel and a needle. So what happens is you have current going through this little bundle, and it's very sensitive and it's well balanced, and the needle will move based on the amount of amperage. If you look at those old amplifiers, come on, you must have seen one of those, right? The amplifiers where you have two needles moving left and right. That's what's happening. There's a coil wrapped around a barrel, and this barrel is resting on very good bearing like needles. Huh?
Like an equalizer.
Equalizer,
Yeah.
but now they're all digital.
Yep.
And it moves based on the vibration. Also, if you look at the rectometer that measures the hurricanes and vibration, it does the same thing. You want something that's balanced and it will move very slowly. So this is what it looks like. And this is what you see in here. If you look at this thing, it's not very stable. I can move it. Move and move. You see? There's a wheel inside and it does move. Maybe I should look at this one. No, it looks nice. But this is what happens. And what I think is one of the issues with the needle movement. If you move it, what else? It was designed to work at a certain position, so you have to set it either in the back or in the front, otherwise it's not going to give you an accurate reading. And also think about interpreting those numbers. It gets a little bit intense a little bit. Let's look at the numbers in between. So between 25 and 50 there are 5 digits, so depending on how clean your glasses that day and how you feel, you might get more and less than you're supposed to. However, for our intended purposes, not that involved. Okay? I feel like Mr. Maggie from South Park. Mr. Mackey, is that his name?
Yeah.
How does an ammeter work?
Strength of the magnetic field determines the distance that the needle and the meter moves.
Okay. In other layman terms,
Electromagnetic, it's measuring that.
yeah. So there's an electromagnetic field that is being measured. So you induce your own electromagnetic field in here. If you look here, if you notice, there's a small piece of metal. You see? So they connect together. You have a magnet, and the strength of that magnet is measured by the ohmmeter, and the magnet going through the wire will interact with it, and you can measure that. You see, there's a connection here and a connection here. So you close those two, and it should give you a reading. Okay. What are the two types of ammeter, and which type is more commonly used in the industry? So there are two types.
Clamp on and bolt on.
Say that again?
Clamp on and bolt on.
Yeah. So the clip-on is the one with clip-on, and the bolt-on is something that looks like that, and it has to be connected in series with the circuit.
Said clip on.
Bolt-on, or like regular multimeter. So this one will measure amperage, but you have to connect it in series. And not a lot of people do that because it's very annoying. You have to find an opening, or take one of the components and put your multimeter on. Okay.
So the clip-on is really
Yeah, it's more common. What is the result of the meter reading of clamping the jaws of a clamp-on meter around two wires?
Zero.
Everybody agree? We did that plenty, and I made sure that everybody does that in the lab so you understand how it happens. And it's one of the things that will show whoever you're interviewing with, or whoever you're working with, that you had no idea how to use an ammeter. And it's a very basic thing. So make sure you understand what's happening here. And mistakes do happen. Sometimes you're clever enough to thinking it's one wire, especially when it comes to something like that. What are you gonna do? You can't really like clip in both. So either you're gonna have to connect something with two wires and clip it in one, or like you have to part these apart a little bit. How can a very small amperage draw be measured with a clamp on meter? That was a question on the lab quiz, lab sheet. So, if it's very, very small, you can either connect the multimeter of this type into microamp, which we don't understand, we don't believe it's microamp. And the other way is doing what? Huh? Anybody? Come on, Renee, come on.
Huh?
How do you measure very small amperage?
By putting it to small as a second.
But that's micro. I have milliamp. What do I do?
Click
Huh?
around the wire.
Yeah, but it's very small. I'm not seeing anything. I'm seeing zero.
Go around.
Yeah.
Yeah,
So you're gonna go 1, 2, 3 until you get a reading. You go wrap it around. And how many loops we have? 1, 2, 3, 4. Whatever number I get, I divide by 4.
Oh, I was gonna say you have to do that.
Yeah. So this is a good way to figure out good reading. And also to verify your reading. If you get 0.015, you want to make sure you double it. And if it reads well, then you get the right reading. Okay. If a conductor was wrapped around the jaws of a clamp on meter 4 times, the proper reading would be? Would be 4, because you have, it was wrapped 4 times and you get 16 amps. So then divide by 4. Everybody got that?
So you divide it by.
The number of loops. How many times you wrap? Explain the operation of an analog voltmeter. We don't have to, but basically the voltage will run through the multimeter and we'll run some amperage through the needle, bundle, is it a pulley or bundle, I don't know, coil, and to move the meter, but you don't need to know that. Air conditioning or refrigeration equipment can operate properly at what percentage above or below the rated voltage?
10%.
Let's look here. There's a certain number for that, and I want to get the right number. I will say 5%, but or 10%, but let's see.
Isn't it 10% at 110?
10%.
5 at the smaller?
Yeah, 10% or above.
Go
or
with the
below.
book. 10%. Above or below. Let's see. Page 74. Highlight it. Okay. All right, we'll finish these on Friday, and we'll do the quiz also on Friday. Okay? Thank you.